Okay, so let's see, where were we, guys? Oh, yes, h of f of g of 3. So let's write that out. H of f of g of 3. Sometimes that helps me. I don't know. You might not. You might just be able to see. I may do g of 3 first. That's fine. So g of 3 is 3 squared plus 1, which is 10. So I'm taking h of f of 10. And when I put 10 in the f function, 3 times 10 is 30 minus 1 is 29. And then when I take h of 29, 29 plus 1 is 30, divided by 3 is 10. Okay, so you just have to wrap it, just keep going from the inside parenthesis out. All right, so that's composition of functions. That's probably nothing too new. Okay, now when we want to just write f of g of x, okay, again, I'm writing f of g of x, and you might just see it as fog, okay, f of g, but the x is implied. Okay, so I'm taking f of, what was g of x again? X squared plus 1. F of x squared plus 1. That means put x squared plus 1 into the f function. The f function says take 3 times whatever's in the parentheses and subtract 1. 3 times whatever's in the parentheses and subtract 1. So that gives me 3x squared plus 3 minus 1, which gives me 3x squared plus 2. That's what f of g is, okay? G of f, that is g of f of x. Okay, that's what that means. So f of x is 3x minus 1. I'm taking the g function of 3x minus 1. Well, the g function tells me to take what's in parentheses, square it, and add 1. So I'm going to do that. Take what's in the parentheses, square it, and add 1. Many people will make a mistake here and write this as 9x squared plus 1. This is 3x minus 1 times 3x minus 1. If you have to write it out, write it out. Okay, and FOIL it and don't miss that middle term. That gives me 9x squared minus 3x is minus 6x. Negative 1 times negative 1 is plus 1. And then we have this plus 1. So the answer to g of f of x is 9x squared minus 6x plus 2. Okay? Now, if they ask me for f of f, that just drives people nuts sometimes, right? F of f. Now, remember, the f function is, what did we say the f function was here? 3x minus 1. You can see it on your graphic organizer. I'm moving my little video screen around here, so I lost it. So I'm taking f of 3x minus 1. So the f function says, hey, take what's in the parentheses, multiply by 3, and subtract 1. So I'm going to take what's in the parentheses, multiply it by 3, and subtract 1. 9x minus 3 minus 1 is 9x minus 4 is the answer to that last one. 9x minus 4. Okay? 9x minus 4. All right? Hopefully you paused me anytime you needed me to be paused. All right. Great. Okay. So the domain, we were talking about with the domain when we add, subtract, and multiply. The domain is the intersection of f and g. Like if we want the domain of f plus g, f minus g, or f times g, then it's just the intersection of the domains. If we want the quotient f divided by g, then it's also the intersection, but you have to be careful to make sure the denominator isn't 0. When it's f of g of x, the domain gets a little trickier. It's the set of all x's that are in the domain of g, okay, the inside function, as long as g of x is in the domain of f. Confusing, right? So if I'm going to find the domain of f of g of x, okay, what I'm saying is I look at the domain of g of x, which happens to be, let's see, not all reals, huh? 3x minus 2 can't be 0. So add 2, divide by 3. It looks like the domain of g is the set of all x's as long as x is not 2/3. Or if you're going to put it in set builder, or I'm sorry, that's set builder notation. If you're going to put it in interval notation, we would say negative infinity to 2/3 in union with 2/3 to infinity. That's the domain of g, which is great. But I would like to say, okay, that's the domain of f of g. I have to be careful that nothing in here is something that's not in the domain of f. So let's think about what's in the domain of f. What can I have in the denominator here? Right? I can't have 1. Okay? So this is all x's as long as x isn't 1. So what I want to make sure is after I use this with the domain of g, what if that number happens to be 1 and then I try to put it in f? Okay? So you want to make sure that this 4 over 3 minus x, or 4 over 3x minus 2, where does that equal 1? I have to solve this little rational equation, which is why we solved rational equations in our first unit. I'll multiply each side by 3x minus 2, add 2, divide by 3, you get x equals 2. So what we're saying is, what if, because 2's in this domain, right? It's as long as x isn't 2/3. But if I let x be 2, then when I find f of g of 2, then I find g of 2. 3 times 2 is 6. 6 minus 2 is 4. 4 divided by 4 is 1. I stick 1 in for f of x. Wait, I can't. That gives me 0 in the bottom. That's what we mean by as long as the g of x is in the domain of f. So the domain of f of g is the domain of g excluding any values such that g of x equals 1. So its domain is actually negative infinity to 2/3 in union with 2/3 to 2 in union with 2 to infinity. I have to include 2 as something that's not in the domain. Or in set builder notation, I could write it like this. All x's such that x is not 2/3 and x is not 2. Either one of those is fine. Guys, another way, if that's going to confuse you, and I often do it this way, I just find f of g of x. Okay? So, in other words, I'll take f of g of x. Okay, so I'm going to, let's see, the f function says take 5 divided by whatever's in the parentheses minus 1. So I'm going to take 5 divided by 4 over 3x minus 2 minus 1. I know that's a mess, but we know how to simplify these types of things. Okay, if I find a common denominator, that'll be 5 over 4 over 3x minus 2 minus 3x minus 2 over 3x minus 2, if we want to do it this way with a common denominator. Okay, and then that'll be 4 minus, be careful, 4 minus 3x plus 2. Okay, because I have to make sure I subtract that entire thing over 3x minus 2. And when I divide by a fraction, I multiply by the reciprocal. So this is 5 times 3x minus 2 over, what is this, 6 minus 3x? Right? because of the 4 plus 2. Okay, so I'm multiplying by the reciprocal. So that gives me 15x minus 10 over 6 minus 3x. And then that helps me find the 2. I can see then that 6 minus 3x, x can't be 2. Okay, so what I do sometimes is I make sure I take the domain of g of x, the inside function, which will give me the 2/3, and then I also find f of g of x, and that will sometimes give me that part as well. Okay, I know that's a little bit tricky. All right, let's try another one. Find the domain of f of g of x for this one. Domain of g, let's see, I can't have negatives, so 3 minus x has to be bigger than or equal to 0. Negative x has to be bigger than or equal to -3, so I guess x has to be less than or equal to 3. That makes sense. Yeah, so we have negative infinity up to 3. G, -2 is about as small as I can go there, right? -2 to infinity. -2, okay, the x plus 2 has to be greater than 0. So x has to be greater than -2. All right, so those are my domains. For f of g, I just have to be careful here. For f of g, I'm going to look at g of x, okay? And I'd like to say it's -2 to infinity, but I'm wondering if any of those things are going to give me something that when I put in here, you know, I just have to make sure that I don't have anything less than, or yeah, less than 3, right? From negative infinity up to 3. So let's find f of g and just see if that helps us. F of g of x, the square root of 3 minus x plus 2. Well, if I'm doing the square root of 3 minus x, I know I'm just doing stuff from negative infinity up to 3, right? Maybe it'll help you to do this. Okay, that's all that. And then for this, we want -2 to infinity. That's the domain of g, right? So if I just use the domain of g, okay, I'm not going to be using any of those numbers anyway. Does that make sense? So this time we were fine in just having it be negative infinity up to 3. If you can somehow, I'm trying to think how, okay, so the domain of g is what I'd like to use, but none of those can give me numbers outside of this domain. Okay, so once you graph it, sometimes if I see the overlap, you know, then you can find, okay, I'm going to have to just use from negative infinity up to 3. Try something bigger than that. If I try something bigger than 3, like 5, I can't, because 3 minus 5 gives me a negative. I had to go with my inside function this time. Okay, negative infinity up to 3 is all I can use for f of g of x. Okay, for this one, go ahead and try to find that one on your own. Okay, hopefully you paused me for a minute and got the domain for f, I can't be 2. The domain for g is negative, everything from -4 to infinity, as long as none of those numbers give me 2. So let's see. Where's the square root of x plus 4? Is that ever going to equal 2? Let's square both sides. S plus 4 equals 4. Oh, when x is 0, that gives me 2. So the domain was everything -4 to 0, and union was 0 to 2, or 0 to infinity. You couldn't be 0.